Open Part 1 of the National Building Code of India, and you find a dense alphabetical list of terms. It is standard practice to treat the section like a glossary, a reference document consulted only to look up isolated words after an inspector flags a permit application. These definitions actually function as interlocking constraints. When applied together, they construct a rigid, invisible, three-dimensional coordinate system that dictates exactly where and how a project can exist. Reading these terms linearly obscures their spatial matrix, leading directly to physical construction crossing invisible legal lines, a very expensive design failure. To understand how the code governs space, we need to build a compliant structure from scratch, translating the raw text into a unified geometric model. Compliance requires translating these separate definitions into a functional spatial engine. Every project starts on the XY plane with the site. The code defines this as a parcel of land enclosed by definite boundaries. Adjacent is the street, defined specifically as an accessway over which the public has a right of passage. The exact side limit dividing that public right-of-way from the private plot establishes the first hard boundary, the street line. Construction cannot sit directly against the plot edge. The authority mandates a setback line, a boundary drawn parallel to the plot lines, beyond which no construction can occur toward the site boundary. This perimeter limit is frequently conflated with the building line, but the two serve different geometric functions. The code explicitly defines the building line as the maximum line up to which the plinth of a building adjoining a street may lawfully extend. Before a single foundation is dug, these interlocking two-dimensional lines have already locked the project's maximum possible footprint. With the horizontal plane set, the regulatory model extrudes into the z-axis, starting exactly where the structure meets the earth. The plinth is the portion of a structure between the surface of the surrounding ground and the surface of the floor immediately above it. This base mass dictates the covered area, defined as the ground area covered by the building immediately above the plinth level. This calculation diverges from the physical shadow. The code mandates statutory subtractions. Utilitarian structures, like a watchman's booth, pump house, or uncovered pool, are excluded from the covered area. The same applies to infrastructure. Geometrically, the code ignores drainage culverts, catch pits, and compound walls. Accurately sizing the covered area relies on identifying these legal voids as much as metaphysical mass. As the structure extrudes vertically, the boundaries dictate the internal volume. A story is the space between any floor and the floor directly above it. Within it, room height is measured from finished floor to ceiling. Without a finished ceiling, measurement terminates at the underside of joists or beams, ignoring the higher roof deck. These internal volumes stack until they hit the ultimate z-axis constraint, building height. This measurement depends entirely on roof typology. For a flat roof, building height is measured from the average ground level up to the terrace of the last livable floor. For a pitched roof, the measurement path changes. The height stops exactly at the point where the external surface of the outer wall intersects the finished surface of the sloping roof. For gables facing the road, the legal apex is calculated as the precise midpoint between the eaves level and the ridge. The legal boundary of building height shifts based entirely on the geometry of the roof, rather than the highest physical point of the structure. All of these individual spatial limits feed into a single mathematical output regulating real estate density. This chart shows the floor area ratio, or FAR. It is the quotient obtained by dividing the total covered area, or plinth area, on all floors by the total area of the plot. This density calculation is tethered to the structure's occupancy, or use group, which is the principal purpose the building is intended to serve. Shifting purpose triggers an alteration, defined as a change from one occupancy type to another, or any structural change to the area, height, or egress. Under this definition, an alteration acts as a regulatory reset that reopens the entire spatial model, subjecting the new geometry to a full compliance review. Ultimately, the FAR is the final output of applying every horizontal setback, volume exclusion, and height calculation accurately. When we assemble the logic, the strict architecture of the code emerges. The setback and building lines lock the x and y coordinates. The plinth and covered area calculate the maximum permissible massing at ground level. The distinct measurement protocols for roof intersection cap the vertical limits on the z-axis. The National Building Code operates as an interconnected geometric engine. Translating its text into three-dimensional logic is the only way to design with absolute compliance.